Okay, we are preparing for a Unit 2 test. So I am going to go over this Unit 2 review, and hopefully you will be very prepared by the time you've watched all these videos, if you choose to watch them. All right, number 1. It says, select the algebraic expression that represents the verbal expression, the sum of twice a number and 8. So first I look for any switch words. More than, less than, subtracted, from, fewer. And there's no switch words, so I am just going to write as I read from left to right for the most part. So I do need to know what the sum means. So when it says the sum, it means you want to add two things together. Okay, so if I keep reading, I'm going to know what to add together. So I want to add twice a number. Twice a number means to multiply a number times 2, so 2n, and 8, so 8. So the sum means add, so I'm adding together twice a number and 8. And my answer is, ding, 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 answer choice A. And of course, this could be any letter you wanted. I just saw that the answers had n's, so that's why I used an n. But you could use x, you could use whatever. Okay, next one. We are trying to solve this equation for y. I'm going to recopy it over here so I have a little more space to write. Okay, so I know that I need to get rid of this fraction. So I'm going to multiply by the least common denominator, and the least common denominator is 2, because that's the only thing in the denominator at all. So I'm going to multiply this entire equation by 2. So I'm going to take 2 times 1/2 y and 2 times 8. Well, if you take 2 times 1/2, that's 1. So all you're left with is 1y. And if you take 2 times 8, you get 16. So your answer is answer choice A. Okay, next one. This is an absolute value inequality. So there will be 2 equations that I set up, but I can't set up the 2 equations until I have the absolute value bars by themselves. Once the absolute value bars are by themselves, that's when I'll write my 2 equations. So just remember, absolute value bars always involve 2 equations, okay? So to get rid of this 2, I do not distribute it, I divide it. Since the 2 is smushed, it is being multiplied, so to get rid of it, I'm going to divide both sides by 2. So then 2 divided by 2 is 1, so those just cancel. Shoop. I'm left with the absolute value of m plus 7. Bring down my sign. And then 8 divided by 2 makes 4. Okay, now that the absolute value bars are by themselves, I'm ready to write my 2 equations. So the way it works, you take what's inside the absolute value bars and recopy it, and recopy this right here. Then I'm going to take the opposite of what I see inside, m plus 7, and recopy this. So you take what's in there and recopy. Then you take the opposite of what's in there and recopy. But I do need to know if this is an and or an or problem. So this is a greater sign, so great or, little memory device there. If it was less than, it'd be an and problem. But if it's a greater than sign, it's great or. So this is an or problem. Okay, so I'm going to work the left equation, and then I'm going to work the right. So the left equation is easy. To get m by itself, I get rid of addition of 7 by subtracting 7. So 7 minus 7 zeroes out. Shoop, the m comes down. Your symbol comes down, and then 4 minus 7 makes negative 3. Okay, I'm going to recopy my word or. And then this one, this is like a negative 1 smushed against that. So since the negative 1 is multiplied, I'm going to get rid of the negative 1 by dividing. So I'm dividing both sides by negative 1. So anything divided by itself is 1, so those negative 1s cancel out. So your m plus 7 comes down. Now, because I divided by a negative number, I have to flip this inequality sign. So flip. And then 4 divided by -1 makes -4. Okay, so I need to keep going until m is by itself. So to get rid of addition of 7, I'm going to subtract 7 on both sides. And then 7 minus 7 is 0. Shoop, that goes away. The m comes down, the symbol comes down, and -4 minus 7 makes -11. Okay, I am going to try to graph this and make sure that it is what I see here. I can already see what I wrote down in this section here, but sometimes they turn out to be all real numbers, these OR problems, or they might turn out to be something different. Okay, so I'm going to make a little graph of it up here. So I always put the smaller number on the left, so -11 is going to go on the left, and I put the bigger number, which is -3, on the right. So the thing about these OR problems is either one of these can be true. So basically, I'm going to graph this answer, and then I'm going to graph this answer, and however the graph looks, that's the answer. So this would be an open circle at the -11, and it says m is less, so I want numbers less. Well, less is to the left. And then this one would be an open circle at the -3, and it says m is greater, and greater is to the right, so I would shade to the right. Okay, if I would have ended up shading the whole number line, then that would have been all real numbers, but because I didn't end up shading the whole number line, then that is out. And there's nothing special that happens to this, so the answer is exactly what we see right here. And so if I look over here, where do you see it? Answer choice D. Okay, next up, number 4. I'm sorry, I'm already running out of room to work my problems, so got to make a little space for number 4 here. So I'm going to recopy number 4. All right, so this does not have absolute value bars, so there's not going to be 2 equations. You're just trying to get y by itself here. So to get rid of this addition of 4, I'm going to subtract 4 from both sides. 4 minus 4 zeroes out. Shoop. Your 0.9y comes down, your symbol comes down, and now I'm going to take -2.3 minus 4. So -2.3 minus 4, and I get -6.3. Okay, and then to get the y by itself, do you know what you would do next? You would undo this multiplication with division, so we're going to divide both sides by 0.9. So that makes 1, so all I have left is y. Now, because I divided by a positive number, I do not flip the sign, so no flipping. Only flip the sign if you divide by a negative or multiply by a negative. Now I need to take my -6.3 and divide by 0.9. So I'm going to divide by 0.9, and I get -7. So y greater than -7. So if I look up here at my graphs, I would want an open circle at the -7, and that has an open circle at -7. That one doesn't. That one doesn't. That one doesn't. So bing, 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 I know my answer. And y greater means you would shade to the right. So sure enough, answer choice A is the one I want. Okay, number 5. So let me recopy my equation off to the side here. So I know that because there are absolute value bars, this will end up with 2 equations. But remember, you can't write the 2 equations until the absolute value bars are by themselves. So to get rid of addition of 6, I need to subtract 6 from both sides. So this way, 6 minus 6 is 0. Shoop. Your absolute value of y minus 8 comes down. And then on the right side, 15 minus 6 makes 9. Okay, now that the absolute value bars are by themselves on one side of the equals, I'm ready to write my 2 equations. So I take exactly what's in here and I recopy the equals 9. If this is an equal sign, this is always an or. A greater than sign, great or is an or problem. A less than sign, less than is an and problem. But an equals is just an or. Okay, then I take the opposite of what I see in here and I recopy the equals 9. So now I just need to solve these two equations here. Okay, so this equation on the left, to get y by itself, I get rid of subtraction of 8 by adding 8. So I'm going to add 8 to both sides. So negative 8 plus 8 is 0. Shoop, drop your y, drop your equals. And then 9 plus 8 makes 17. I'm going to drop my or. Okay, remember this is a negative 1 smushed, and when it's smushed, that's multiplication, so I'm going to get rid of it by dividing. And I could get rid of it by distributing, but I thought we'd try something different today. So negative 1 divided by negative 1 is 1, so those just cancel out. So all you have left is y minus 8. And then 9 divided by negative 1 is negative 9. Okay, so to finish solving this equation, to get y by itself, I need to get rid of subtraction of 8 by adding 8. So I'm going to add 8 to both sides. The negative 8 plus 8 cancels out. Shoop, all I'm left with is y, the equals, and then negative 9 plus 8 makes negative 1. Okay, so when I look over here, I see that I have 17 and negative 1 for an answer, and I do see 17 and negative 1, but I need to check them. I need to make sure they both work, because if one of them gives me an error, it doesn't work out, then I would either want just the 17 or just want the negative 1. Or maybe both of them don't work, and then I would want no solution. So I do have to take time to check them. Okay, so I am going to take this 17 and I'm going to plug it back into the y of the original problem. So if I do that, I'm going to put 17 here. I'm going to take 17 minus 8. So 17 minus 8. And then I'm going to recopy. Plus 6 equals 15. And I need to see if this is true. So 17 minus 8 is 9. So I have the absolute value of 9. Recopy. The absolute value of 9 is 9. Recopy. And let's see. Does 9 plus 6 make 15? Yes, it does. Check. So I know that 17 is an answer. It works. Okay, now I need to take this negative 1 and put the negative 1 into the y. Okay, so the negative 1's going right here, so it's negative 1. Recopy minus 8. Recopy plus 6 equals 15. Okay, so I'm going to work what's inside the absolute value bars. So negative 1 minus 8 makes negative 9. I'm going to recopy. The absolute value of negative 9 is also a positive 9. Absolute value has to deal with your distance from 0. And if you are at a negative 9, you are 9 units away from 0. And if you're at a positive 9, you're also 9 units away from 0. So anytime you take the absolute value of something, it always comes out positive. Let's recopy. And does 9 plus 6 make 15? Yes, it does. Check. So since both answers work, then that means the answer is C. But you do have to check them, because if only one of them worked, it would have either been A or B. And if neither of them gave you a true statement, then it would have been no solution. Okay, this next one, I am going to graph it, and I'm going to identify the range. Okay, so I'm going to use my graphing calculator here. So I'm going to go to y equals. So I'm going to type the negative. To get to absolute value, I hit math. Then I go right arrow to number, and then it's number 1. And I know a lot of you have to use Desmos. which you could do that too, plus 3. Okay, now I'm going to hit graph and look at it. So remember, range is asking what are the y's doing. So the graph goes forever down, but not forever up. So I need to find the y where it begins. And that is a 3. That's where the y begins. So y starts out equaling a 3. And then when the graph goes down, 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 y's get less. And so that's my range, y less than or equal to 3, which is answer choice B. Okay, on to the next page. All right, number 7. They give us this formula, and the measure A of an interior angle of a regular polygon to the number of sides n. Okay, so A is representing the measure of an interior angle. So that's what A is talking about. A is the measure of an interior angle. And n is talking about the number of sides. Okay, so it says, if an interior angle measures 108 degrees, find the number of sides. So this right here, do you think they gave you the A or did they give you the N? They gave you the A. This is what the interior angle measures, so that means that this is the A value. So you're going to put this 108 boop, into the A. And since they say find the number of sides, that means you're going to solve the equation for N. Okay, so here we go. 108 boop, goes into the A. And then I'm going to recopy the right-hand side. Now, there's lots of different ways to solve this equation. I am going to set up a proportion by popping this side over 1. A proportion is when you have one fraction equal sign one fraction. And you learned a long time ago you solve proportions by cross multiplying. So I take 108 times n, which is 108n, and then I multiply the other diagonal. And 1 times anything is the anything. So that side makes 180, parenthesis n minus 2. So whenever you multiply by 1, you just get what you started with. Okay, so to solve this, I'm going to distribute to get rid of my parentheses. So 180 times n is 180n. 180 times negative 2 is negative 360. And then I'm going to drop my 108n. Okay, so now at this point, I see that I have n's on opposite sides of the equations, and I need to bring them to the same side. Don't move this guy, because he's the only thing over there. Move this guy. So to get rid of a positive 180n, I have to do the opposite and subtract 180n. So I need to take 108 and subtract 180. So just to show you, 108 and I'm subtracting 180 makes negative 72. So I've got a negative 72n. 180n minus 180n makes 0. Shoop. I'm going to drop the negative 360. And then to undo this multiplication, I divide. So I'm going to divide both sides by negative 72. So now I need to take negative 360 and divide by negative 72. So negative 360 divided by negative 72, and I get 5. That means that this shape has 5 sides, and 5 is answer choice A. And there's other ways you could have solved this. So you might have solved it differently than me, and that doesn't mean that you're wrong. Unless you got the wrong answer, and then you're wrong. Okay, number 8. Which of the following does not represent an attribute of the function f of x equals the absolute value of x? Okay, let's graph it and take a look at it. Now, you should already know what this looks like without having to graph it, but if you don't, no big deal. So I go to y equals absolute value. I hit the math button, right arrow to number, and then number 1 is what I want, and then I'm going to put an x in there. All right, let's just look at it. All right, so A is talking about domain and range. So domain, this graph goes forever to the left, forever to the right. So that means domain is all real numbers, also known as negative infinity to positive. That's true. Range, the lowest y is 0, and it goes up, 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 up. So that means it goes to positive infinity. So this is true. Okay, so both of those are true. The vertex is the lowest point of the graph right here. So that is a minimum, and it is happening at 0, 0. So that is also true. C says the x and y intercepts are 0, 0. And that's true also. This graph touches the x-axis at 0, 0, and this graph touches the y-axis at 0, 0. So that is also true. So that means that this one must not be true. And the reason it's not symmetric over the line y equals 0, it's symmetric over the y-axis, but the y-axis is a vertical line, which is a vux. So this would be x equals 0. The graph is symmetric to x equals 0, not y equals 0. So that's why this guy is false. And that's what we want. We wanted to know which one is not true, and D is not true. Okay, number 9 here. A packaging company fills bags of chips on an assembly line. The bags are supposed to weigh 12 ounces, but there's a tolerance of variation of 0.4 ounces. If a bag is outside this range, it is rejected by the machine and must be emptied and the bag disposed of, creating waste. Which equation can the company use to show the heaviest and lightest weights acceptable for the chip bags? Okay, so the way this works, it's always x minus what you want. And equal to the variance. So, following this pattern, it's going to be absolute value of x minus, what do I want this bag to weigh? Well, they're supposed to weigh 12 ounces. So that's what we want them to weigh. But there is a tolerance of 0.4 ounces, meaning it could be 0.4 ounces more than this, so it could be 12.4 ounces, or it could be 0.4 ounces less than this, which means that it could be 11.6 ounces. So these bags could weigh anywhere from 11.6 to 12.4. So the variation goes right here. And if I look over and I see it, I see that it's answer choice B. Now, I could always work this out, and if I work this equation out, I would get 12.4 for an answer, and I would get 11.6 for an answer. And that's okay for the weight to be somewhere between 12.4 and 11.6, because it says that there can be a variance of 0.4 ounces. Okay, next one. If the parent absolute value function is transformed according to this rule, how will the graph of the function change? Okay, numbers out in front. Remember, if numbers out in front are bigger than 1, it's called a vertical stretch. So if numbers out in front are bigger than 1, it's called a vertical stretch. Well, when things stretch, they go and they get skinnier. So it will be skinnier, or it looks like those answer choices over there are using the word narrower. If it's inside the parentheses, it's left or right, but remember it's opposite of what your natural thought would be. So a plus inside is going to make the graph go left. So it's going to go left 3. And the number in the back makes the graph go up or down, but it does what you think. And so a minus 6 would make the graph go down 6. So I'm looking for a vertical stretch, narrower, left 3, down 6. And do you see it? Right here. Down 6, left 3, narrower. Bing, 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 bing. We have the correct answer, folks. Okay, let's look at number 11. All right, so I'm going to write the equation over here so I have some room to work. Okay, I'm back to an absolute value equation. So I know I'm going to have two equations, but I can't write them until the absolute value bars are by themselves. So to get rid of addition of 5, I subtract it. So 5 minus 5 is 0. Shoop. Your absolute value of x minus 6 comes down. And then 4 minus 5 makes negative 1. I know the answer right here. Do you remember how when you take the absolute value of something, it always comes out positive? For example, the absolute value of 6 is 6. The absolute value of negative 6 is also 6. Because absolute value talks about the distance something is from 0. And so absolute value can never equal a negative number. Well, look what we have. Absolute value equaling a negative number. And absolute value can never equal a negative number. So I'm going to stop working. This is no solution. Okay, I'm going to stop this video and then I'm going to start another one with number 12.